Okay, 9B part 2 video. This is second take on this thing here. I wanted to sort of change it up a little bit. So suppose we had a problem like this. You buy a $100,000 house and the value of the house increases by 30% every 5 years. And increases by 30% every 5 years. What rate does a house appreciate per year? And what will the house's value be after 12 years? All right. This is a little bit complicated, and so it's going to sort of take an extra step. So one thing that we cannot do, okay, we cannot do this. If it increases by 30% every 5 years, we cannot just do 30 divided by 5 and say it increases at 6% per year. Okay. All right. We cannot do that. That's wrong. Okay, because percentages are not linear, so we can't just divide those two things. So we need to go about it in a different way to find our B value. Coming back to our thing, our exponential model, y equals a times b to the x power. B is the rate that our thing grows or decays in 1 year. Okay, in 1 year. But when they give us it increases by 30% every 5 years, that's a problem. And so we need to fix that and sort of make that and find out what that would be in 1 year. Okay. And here's how we're going to do this. If there's a 30% increase every 5 years, we're going to take our growth or decay factor, which is going to be 1.30, because that's 30% increase. 30% increase is 1.30. And we're going to raise it to the 1/5 power. All right, we're going to raise it to the 1/5 power. In the previous video, I calculated it, and here I don't want to calculate it because it's going to give us an answer that's a little off, and I want to sort of be as precise as we possibly could here. Okay, so our B value is going to be 1.30 to the 1/5 power. All right, so our proper B value is going to be 1.30. It wouldn't be a bad idea to put parentheses up here and raise that to the 1/5 power. All right, so that's our B value. That's our B value, 1.30 to the 1/5 power. Again, don't calculate it because our answers are going to be a little bit off, and I can maybe show you that later if we need to. All right, so what will the house's value be after 12 years? Okay, well, after 12 years, so now we can figure this out, okay? Because we know our A value, we'll come back up here, our A value is 100,000. All right, our B value is 1.3 to the 1/5 power. All right, and our X value, if we're going for 12 years, is going to be 12. Okay, so 100,000 is our A, 1.3 to the 1/5 power is our B value, and our X value is 12. So how we're going to do this in the calculator is, I'm going to come down here to do this. So we're going to have Y equals 100,000 times 1.3. We're going to raise it to the 1/5 power. All right, and we're also going to raise that to the 12th power. Okay, so to break this thing down, ladies and gentlemen, the 100,000 is our A. 13 to the 1/5 power is our B. The 12 is still our X and the exponent right there. If we come over into our calculator, so we're going to have 100,000 times 1.3, and we're going to raise that. I'll do parentheses there, 1 over 5. And we're also going to raise that to the 12th power just like that. And that's going to give us our answer. So it's going to be $187,000, $699 and 90 cents. So 187,699.90. All right, so what's the house's value going to be after 12 years? $187,699.90. And in case we're not sure, in case we forgot about the first part, what rate does a house appreciate per year approximately? Again, the appreciation per year is just going to be your 1.30 to the 1/5 power. If we wanted to calculate just that, all right, 1.30 to the 1/5 power, we could do that to get an approximation. I don't want to have to do this though, because again, what happens is we're going to get some numbers that are a little inaccurate if we do it there. So 1.30 to 1/5 power is 1.0, call it about 1.054, 1.054. All right. And 1.054, I know I'm kind of running out of room here, is about 5.4% per year. All right. Again, I'd rather you guys do it the way I sort of did it in the purple there, but if we need to calculate just the B value and nothing else, and we don't need to plug it in or anything like that, we can go sort of here. We're going to do one more on the bottom here just to make sure that we're good, and then that'll be it for the notes portion of this, and you can work on the practice problems independently. All right. Example 2. We buy a car for $30,000 that loses 23% of its value every 2 years. What will be the car's value after 5 years? All right. So our A value, 30,000. B value. All right. Our B value, again, so we lose 23% of our value every 2 years. So let's start with, if we lose 23%, all right, we know that's going to be 1 minus 0.23. And we lose that value every 2 years. And so what's going to happen is we're going to raise that to the 1/2 power. Okay, we lose 23% of our value, so what we're left with is 1 minus 0.23, which is 0.77. So the 1/2 power. So that's ultimately going to be our B. What's going to be the car's value after 5 years? Well, the 5 years, that's our X. And so what we will type in here, ladies and gentlemen, is we're going to do 30,000 times 0.77 to the 1/2 power. And then we're also going to raise it to the, X is 5, so we're going to raise that to the 5th power. So 30,000 times 0.77 to the 1/2 power to the 5th power. All right. Come over here, 30,000 times 0.77 to the 1/2 power. Let's put parentheses around that. And to the 5th power. So we're going to be left with $15,608.03. I don't know why this little marker's here. All right, so our final answer, let me rewrite this in a spot that's better. So we calculate this down and we have $15,608.03. Okay. So as simple as that. Again, the hard part is just calculating our B, the same thing yesterday. And so we need to calculate the B the same way we did yesterday. And then, whatever span of time that it loses or gains that value, we need to raise it to 1 over that power to get what it would do in 1 year. All right. So that's that. That's 9B part 2, the second take. And use this to do the back. And again, I can answer any questions that you may need. Take care.